It is indeed required to run an equipment grounding conductor by code in a motor space heater circuit, especially when it's fed from a motor control center, supplemental undervoltage system, or switchgear, even when the motor control center, supplemental undervoltage system, or switchgear are grounded to the building structure. The primary reason for this requirement is safety. The equipment grounding conductor provides a low impedance path for fault current. This low impedance path is critical for quickly clearing ground faults. When a fault occurs, the current needs a clear and direct path back to the source to trip the overcurrent protection device, such as a circuit breaker or fuse. This rapid clearing of the fault minimizes the duration of the fault, reducing the risk of electrical shock, fire, and damage to equipment. Imagine a scenario where a motor's insulation fails, causing the motor winding to come into contact with the motor's metal frame. Without an equipment grounding conductor, the fault current might find its way back to the source through unintended paths, potentially through a person touching the motor. This would create a severe electrical shock hazard. With an equipment grounding conductor properly installed, the fault current would flow through this conductor back to the source, tripping the overcurrent protection device and energizing the circuit, thus preventing the electrical shock. Now, consider the situation where the motor control center is located in one building and the motor is in another building. Even in this scenario, the equipment grounding conductor must run from the motor control center to the motor. The reason for this is that the equipment grounding conductor provides a continuous, low impedance path for fault current regardless of the physical separation between the source and the load. It's not sufficient to rely on the building's grounding electrode system to serve as the primary path for fault current. The building's grounding electrode system is designed to provide a reference point for the electrical system and to dissipate static electricity and lightning strikes. It's not intended to handle the high levels of fault current that can occur during a ground fault. The National Electrical Code, or NEC, provides specific requirements for the sizing and installation of equipment grounding conductors. Specifically, NEC 250.122c addresses the sizing of equipment grounding conductors. It says that equipment grounding conductors should be sized in accordance with 250.122 code through C3, as applicable. 250.122 code covers alternating current circuits and states that for alternating current circuits, the equipment grounding conductor shall be sized as specified in Table 250.122. 250.122C2 addresses direct current circuits and states that for direct current circuits, the equipment grounding conductor shall be sized as specified in Table 250.122. 250.122C3 specifies that for grounding electrode conductors, the equipment grounding conductor shall be sized as specified in Table 250.66. Table 250.122 provides the minimum size of the equipment grounding conductor based on the rating of the overcurrent protective device protecting the circuit. For example, if the overcurrent protective device is rated at 20 amps, the minimum size of the equipment grounding conductor is 12 American wire gauge copper or 10 American wire gauge aluminum. If the overcurrent protective device is rated at 60 amps, the minimum size of the equipment grounding conductor is 10 American wire gauge copper or 8 American wire gauge aluminum. It's important to note that these are minimum sizes. In some cases, it may be necessary to increase the size of the equipment grounding conductor to meet other requirements, such as voltage drop or to provide additional mechanical protection. Failure to run an equipment grounding conductor in a motor space heater circuit can lead to several hazards. Firstly, there's the risk of electrical shock. As mentioned earlier, if a fault occurs in the circuit, the fault current could flow through the motor housing and into the ground, potentially causing an electrical shock to anyone who touches the motor or its surroundings. Secondly, there's the risk of fire. Fault current can cause the motor to overheat, potentially igniting nearby combustible materials. A properly sized and installed equipment grounding conductor helps to quickly clear the fault, reducing the risk of fire. Thirdly, there's the potential for damage to equipment. Fault current can damage the motor or other equipment in the circuit. A properly sized and installed equipment grounding conductor helps to limit the amount of fault current that flows through the equipment, minimizing the risk of damage. It's also important to ensure that the equipment grounding conductor is properly connected at both ends. At the source end, it should be connected to the grounding bus in the motor control center. At the load end, it should be connected to the motor frame or enclosure. The connections should be made using approved connectors and methods. In addition to the equipment grounding conductor, it's also important to ensure that the motor and the motor control center are properly grounded to the building's grounding electrode system. This provides a reference point for the electrical system and helps to dissipate static electricity and lightning strikes. The building's grounding electrode system should consist of a grounding electrode, such as a ground rod or a metal water pipe, connected to the building's main electrical panel. The connection should be made using a grounding electrode conductor, which is sized according to NEC Table 250.66. In summary, running an equipment grounding conductor in a motor space heater circuit is a critical safety requirement. It provides a low impedance path for fault current, helping to protect people and equipment from electrical shock, fire, and damage. The equipment grounding conductor should be sized according to NEC 250.122 and properly connected at both ends. In addition to the equipment grounding conductor, the motor and motor control center should also be properly grounded to the building's grounding electrode system. When dealing with electrical installations, it is always advisable to consult with a qualified electrician or electrical engineer to ensure that the installation meets all applicable codes and standards. They can assess the specific requirements of the installation and provide guidance on the proper sizing and installation of equipment grounding conductors and other grounding components. Proper grounding is a fundamental aspect of electrical safety, and it's essential to take it seriously to protect people and property from the hazards of electricity.